In this example, keep in mind that an element is an item within a set. So for A here we have 65, and here is our symbol for an element. 65 is an element of this set. Now, of course, for this set here, we have an ellipses. And of course, an ellipses shows that the pattern continues. It concludes with 100, but we have to establish a pattern first. And then this pattern continues and it concludes with 100. So obviously we can see here that it is 5, 10, 15, 20, 25. And if this pattern was to continue, 30, 35, 40, 45, 50, 55, 60, 65, 70. So is 65 an element of this set? Since we've established that pattern and we can show that 65 is an element for this set. So I'm just going to go ahead and I'm going to put down that's true. Mark it as T. For B, we have A is an element of this set here. And we can see that A is not an element. We have a capital A, but that's different than the lowercase a here. So A is an element of this set? No, that is false. As we move on to C, Kyle Beckerman is an element of this set. What is this set here? That set is the members of the 2014 FIFA World Cup U.S. soccer team. I don't know how much you follow soccer, but Kyle Beckerman actually was a member of the 2014 FIFA World Cup soccer team. So this is actually true. For D, Steinway, and this is a symbol for not an element. It's the element symbol with a line through it. So a Steinway is not an element of this set here. And what is this set? Well, it's P, such that P is a piano. Steinway is one of the biggest manufacturers of pianos. So it's saying that Steinway is not an element of a piano. Well, that's false. And as we look at these sets, we can see here we have a roster method here. And this roster method uses an ellipses to show that the pattern continues. We have the roster method here. This one lists each individual element that we could see in there as different from this one, which uses an ellipses to help describe it. Here, this is a word description. Now, in previous examples, we did not enclose word descriptions in parentheses, in curly braces here. And the reason we're doing it now is so that we could show whether Kyle Beckerman is an element of this set. If we didn't enclose it in curly braces here, it might be a little unclear. So we just went ahead and we did it anyways, so we can see if this element is an element of this set. Here we use the set notation in order to be able to describe the set. Here we have a roster method again. So for E, it says set 0 is an element of this set. Now this is actually false. Even though we have 0 here, that's not what it's asking for. It's asking for set 0 is an element of this set. So this is actually false. For this to be true, this set would have to look something like this. We would have 123, 17, 67, and rather than just having the element 0, we would have to have the element of the set of 0. It would have to look something like that. And then we'd have 102, 57, 48, and 4. So for this letter E to be true, it would have to look something like this. But it's not like that, so this is false. For F, we have negative 17 is not an element of this set. Now notice this set. This set has two ellipses. We have an ellipses at the end here, showing that it continues on going that way. And then we have an ellipses at the beginning here, showing that this pattern continues going that way. So we can do that. So what this is showing is that it's going from negative, maybe negative infinity, and counting up this way, and going off into infinity and counting up that way. So this says negative 17 is not an element of this. Well, if this pattern was to continue going that way, we would see that negative 17 is an element So this is actually false. And then we have V is not an element of the empty set. There are no elements in the empty set. So this is actually true. And there we have it.